We hit Stack Overflow and Google, and we say we just try to describe a problem. We see something, it proposes a solution to some problem that somebody had that looks like ours. So we quickly try to throw that into the program that we've written, and probably it doesn't work, right? Probably it causes some other problem, or it just doesn't fix the problem that we have encountered. And we're just thrashing around and we're not really getting anywhere. This is the hair. And this often just makes the problem worse. We're adding new complexity to our program. We're adding things that we don't understand into our program and into the system. We're making things worse. And even if we do kind of by accident fix it, you probably didn't learn much. Probably you're like, okay, well, at least that's out of the way. Moving on, let's focus on the next thing. And you're still being the hair and you're not learning. Maybe you can get something across the finish line, but you aren't going to understand very well how it works. So a better response is to be methodical. Be mindful of what you're doing, do one thing at a time, be methodical, be slow and steady. The takeaway here is that sometimes going fast is the slowest way to go, and going slow is the fastest, which is kind of another way of saying sometimes it pays to be methodical. And again, the goal here is to actually understand the system. The goal is to improve your own understanding in your head about what's going on so that you can grow, so that you can improve. And that understanding will pay dividends not only with future bugs, but in your ability to extend the system in various ways because you will understand it. Okay, I want to talk about different kinds of programmers. There's a kind of programmer I like to call a framework jockey. I'm intending this as a bit of a derisive term. A framework jockey knows how to use the framework, and that's about it. So maybe they know they're building web apps and they know how to use Rails, or they know how to use Django, or something like that. And I'm not trying to knock these frameworks. They have their uses. Some people can get along fine with them, and that's fine. But the framework jockey doesn't really understand what the framework is doing. They just know kind of how to use the framework, and that's about it. They can crank out some programs, man. They can fly through that framework as long as things stay on the beaten path and kind of stick to the beaten path. They can crank out some programs and they can fly and be really fast in it. But if things start to get off that beaten path, that can be a real challenge. And a framework jockey might throw up his or her hands and say, I don't know how to do that. No, I can't really go there. That's complicated. And basically it's the idea of like, there be dragons. Like, we're not going to go sailing in the Atlantic Ocean. There be dragons. We don't know. And that's kind of the approach that the framework jockey has. They kind of stay up. I think of this in terms of staying up in the clouds. Like they're living at some level of abstraction, and they don't want to dig deep to understand what foundations they're actually using and building on. So the moral of that story is, don't be a framework jockey. Instead, pursue mastery. So don't just sit on top of the framework and ride it, but pursue mastery. Pursue understanding at a deep level. For one reason, it's really rewarding and satisfying to achieve mastery in something. When you understand how to program in some language well enough that you just conceive of an algorithm and you can just, in a state of creative flow, just express it through your fingertips, it feels great. And that's something that's achievable for all of us. Maybe you've experienced that at times. And it's a good feeling. If you haven't, it's something worth pursuing. I'll say that it is possible to master your craft. You might know this from experience. You might already feel some mastery and know what I'm talking. Know what I'm talking about. You might not. You might feel intimidated by the idea of mastery. It's just like, okay, maybe some people can master this whole thing. I grant that theoretically that should be possible. That's just not me. I don't think I can master this craft. And I would say, I think you can. I think you can. It's a hard road. It takes time, but I think it is possible to do. And one of the ways to do it is to pursue this understanding and not to thrash around trying to throw potential solutions at a problem without having understanding. It's a long road, and it's kind of the long road to try to pursue mastery, but it pays off in the long run. Slow and steady wins the race. And my goal here is not to say that this is going to be an easy thing to pursue mastery. It's work, it's hard, it takes time away from other things that you might be doing that are more fun. But I want to break down what might be the mystery of mastery. Hey, that's kind of a cool turn of phrase. I don't want the pursuit of mastery to be a mysterious pursuit. And so that's what a lot of I'm talking about here is with understanding the system. And so, for example, one starting point on the road to mastery would be a bug, which is what we're talking about today. A bug is an invitation to pursue mastery, because if you see a bug and it's not something that you immediately understand, for example, variable not defined, then this is an invitation to understand things at a deeper level, right? So maybe it's mysterious what's causing this bug, and that's where be methodical. Take your time, try to understand things. I'll break down more in this lecture. Break down more of what you can actually do to pursue mastery and understanding. But take a step back and say, all right, my understanding is not sufficient to immediately grok what this bug is about. This is my invitation. This is my invitation to deeper understanding. And as I pursue deeper understanding at each opportunity pursue more understanding and more understanding, before long, I will have some mastery over this system, maybe over this programming language, maybe over this particular technology and some of the concepts that I'm dealing with in this program, maybe this framework. But if you just listen to those invitations to understand and continue listening over time, you'll get to a place of mastery, and you'll start to, programming will be easier. Everything will be easier when you have that mastery. All right, so this was kind of a long digression, I think a very useful one, but a lot of this is intending to reinforce the idea that bugs are opportunities, and to try to frame that perspective that we can have that is more productive whenever we encounter a bug, rather than feeling frustrated or feeling discouraged or feeling like, oh, now I've got to waste my time chasing down this bug. It's an invitation. It's an invitation to understanding, and continuing to pursue understanding over time is going to get you to mastery. Questions so far? Okay. Either you don't understand how to raise your hand, or I'm really boring, or so far this is clear. I'm going to choose to believe the latter. Oh, I see a raised hand. Okay. Locke, remember to unmute and feel free to share your video if you so choose. I think okay. You missed the last 30 seconds. You were kind of frozen. Okay, I see you just chatting there. yeah, basically the summary is just to view bugs as an opportunity to pursue understanding rather than feeling frustrated or discouraged. Any other questions? Okay, great. Let's move on. So let's break down some of the mechanics of how to understand the system. I mean, just saying like go understand the causes of your bug sometimes doesn't really help. You have to break it down into like what are the actual steps to take. So let's get started on breaking it down. One thing I found to be a really useful resource is there's an article, 7 Tips for Successful Self-Learning. And this is actually an article, I'm gonna pull this up just to kind of show you what's, okay, well, I meant to do that in a new tab, but that's okay. There is this, so a lot of you maybe know about Hacker News. For a while, for a few years there was a magazine called Hacker Monthly that would kind of take the most popular articles from Hacker News and put them into magazine form. I didn't know about this at the time. I think it actually shut down by the time I found out about it, or shortly after. But I went through some of the old catalog of issues, and there was a lot of really good stuff in there. And this was one of the articles that I found. And I read this years ago, and it really stuck with me. It's probably too small to read, but anyway, this is an article you can feel free to look up. 7 Tips for Successful Self-Learning. This is in a nicely typeset magazine format, unlike probably the original, web-based article that showed up on Hacker News so many years ago. This might have been from like 2010 or something like that. So feel free to read this in more detail, but I'm going to talk about this I'm stuck decision tree as well as just some general tips. So let me talk about that. One of the tips, actually, and this is kind of where I'm getting the tortoise versus hare thing, is from this book or this article. Actually, the book talks about it, the debugging book talks about it, and this article book also talks about it. It's just to like expect that you're going to spend some time understanding things. This really does take time, and it pays to be more methodical about this. There's not a quick fix for understanding. There are actually some hacks that you can do to understand things more quickly, but a lot of what it takes to understand things more quickly is understanding. In other words, the more you understand, the more you have kind of a structure in your head that can distinguish between important and unimportant things, and the more equipped you will be to understand the next thing that comes along. Another way to say that would be the more abstractions that you have, the more you can build on those abstractions, and the easier it will be to understand abstractions that build on those. So understanding is kind of a snowball effect. I mean, the more you understand, the easier it is to understand. But it really does, it's a process. It takes time. And if you try to rush it, you're probably not going to actually be understanding. You're probably going to be cheating yourself out of that understanding. So unfortunately, it just takes time. This is one of the biggest obstacles and turnoffs that you can have that turns people off of the idea of understanding. It's hard to spend time doing things like that. Another piece of advice from this article is avoid multitasking when you're trying to understand. Turn off your notifications. You can do that, by the way, in Mac OS with this. If you click on that icon in the upper right-hand corner, you have to like scroll up, and then you can turn on Do Not Disturb. Okay. There are other, your phone can do this. I'm sure Windows has a way of doing that as well. Turn off your chat programs. Maybe close your computer entirely if you can just find a book to read. But just focus. This itself can be a hard discipline if you're not used to it. So if you just can't do this for long stretches, start by doing it for 15 minutes. and see how it goes. And maybe you can build up a discipline of doing that for longer periods of time. Related to the going slow, don't read through books, work through them. There's a toil here of the stuff that actually stretches your mind the most requires the most work. This is kind of like hiking. I've been enjoying some hiking recently. You can't really get to the top unless you put in the work. Maybe you could run to the top if you, have strong enough legs. Maybe you have to walk up to the top. But either way, there's a certain amount of work that you have to do to get to the top. And the same thing is true if you're trying to understand something. That thing is a certain distance above where you are. And there's a certain amount of work that you're going to have to expend to get to the top of that. So you can do that. Maybe you can do that with more intense work. Maybe you can do that with slower paced work. But either way, it's a certain amount of work to get there. And you should expect to work. If you breeze through the book or the article or the manual, whatever, you're probably not actually getting to the top. You're probably not really getting that information and that understanding into your head. Your brain is not reshaping itself to understand that new concept. It's not connecting that new concept to the things that it needs to be connected to. All of those things take work. So be prepared to do the work. I was going to say something about that and I forgot it. Well, okay, but anyway, use a REPL. If you're reading through like Closure for the Brave and True, for example, because you're realizing you don't understand Closure very well, play around with the examples that it gives. Use a REPL. Type this stuff in. Experiment with it. Try it out. See what happens when you change things. A lot of times you don't really get something until you have a chance to play around with it and experience it yourself. Then it starts to click and connect. I know what I was going to say. Think of your mind as an organ, much like your stomach. All right. You eat food, right? It goes to your stomach and your gut, more generally, your digestive system, I should say. Your body has to digest that food to get the nutrition out of it. And that's a process. And, that takes work on the part of your stomach and your gut to do. But it's a process. And after that process is finished, your body, not to get too gross about it, but it separates the stuff that you need and the stuff that's useful from the stuff that's not, and the waste. Gets rid of the waste, and the stuff that you need becomes literally a part of you, right? Your body uses this and it becomes part of your body. So in the same way, your mind is an organ for digesting, right? You're not digesting physical food and nutrition, you're digesting information and ideas. And your mind has that same process, a very analogous process, I should say, that your gut does for digesting food. You have to consume it, get it in your head, and there's a process of working with this material and connecting it to different things, and sorting out the stuff that's useful from the stuff that isn't. So anyway, all that to say, there's a process there, and your goal is to really consume stuff and digest stuff and make it a part of you, part of your understanding. And that is work. So a couple of examples that might relate from the assignment. How many of you really understood how Closure handles command line arguments until you wrote a program to do it with the Mishmash assignment? You had to write your own -main function that took arguments, and you saw kind of how the command line arguments get conveyed from the command line into your program. And maybe things started to really make a lot more sense once you actually implemented it for yourself. Another example, how many of you really understood what I meant when I initially said that Git is a content addressable database until you actually started to implement one? Probably started to make a lot more sense that way. And the same is true with anything that you're trying to if you experiment with it and play with it and work through it, you'll understand it in a much deeper way. Another example that I've given this advice to a number of you who have been struggling with assignment 3. Work through that example that I gave on how to compute addresses. Play with it. See how it varies when you give it different inputs. Try it out on your REPL. Even if all you're doing is just typing those commands into the REPL yourself, even that's not a bad exercise. Get you used to the process of typing things into a REPL and seeing the result. So anyway, work through it. This is also kind of one of the big motivating reasons for why why I've done the assignments that I've done and picked those. Why I'm making you write Git and write a simple implementation of Git is because I think this kind of mastery that you will have of Git by the end of the semester is going to serve you for the rest of your life as a software engineer. As much as you use software and develop software, you probably will be using Git, especially now that you know it. And if you really have a mastery of Git because you've actually implemented the core concepts, I think that's really going to serve you well. That's part of why I'm doing this. So it's not just to torment you, despite what some of you may think. Okay. And then another thing would be when you're not getting something, take a step back. There might be something foundational that you need to learn first. So if you keep coming across this thing and you're like, what is this thing? I don't really get it. I think I understand how the author is using this, but not sure I understand what all he or she means by that. It might benefit you to take a step back and say, okay, I'm going to open up a new tab or whatever. I'm going to go research that thing and try to understand that thing. And once you learn that and get that into your mind, digested, come back to this, pop that off the stack and come back to this. Then things start to make a lot more sense. All right. So that's something that, again, it takes time and it's a hard thing psychologically because you feel like you're taking a step back. Like I'm struggling with the recursion and the right W tree example that Dr. Terry gave in class last time. We covered recursion already in the class I took, 401 or whatever it was. I feel like I should have understood it now. Not really sure I get it. That's okay. And it's hard psychologically to take a step back and say, I'm going to go back and review. But sometimes that's exactly what you need to do. The good news is here that, if you feel dumb, it's probably just because you need to learn or relearn some foundation that's assumed. And a lot of times it's way easier to learn it a second time or a third time. So maybe you struggled with recursion the first time through and you're still not real sure you have a solid handle on it. But if you go back and review it, maybe look at different material of it, different treatment of it, this might be exactly what you need to really get it more deeply into your understanding so that it's more securely a part of you. But, be willing to take that step backwards because it's not really a step backwards, even though it might feel like it sometimes. So it is emotionally difficult to go backwards, but remember, be the tortoise. Okay, so from that article, here is the I'm Stuck decision tree. I'm not sure how easily you'll be able to read this. It's kind of small, so you might want to open up the notes from the webpage. If you go to the calendar of the course webpage and look at the slides from there, you'll be able to go here and maybe see a higher res version of it, or you can see it on your own time. But basically, let me just walk through it briefly here. So if you're stuck, ask yourself, are you familiar with the abstractions that you're seeing in the thing you're stuck on? Are you familiar with these abstractions, whatever they are? If you're not, then you're in this box here. And then let's see, one option here says you know the field, but not this particular concept. And in that case, the thing to do would be to learn the concept and review other parts of the field on demand. Okay, on the other hand, if you're unfamiliar with the abstractions you're seeing and you're unfamiliar with the concepts, terminology, and symbols, you don't even know what field this is a part of, then the thing to do is you will have to step back from your current studies, find out what field you're in that field. I don't think any of you will be here when it comes to material in this course, but you might be in other things. Okay. On the other hand, if you're familiar with the abstractions that you're seeing, there's a few different options here. Okay. You're familiar with the abstractions you're seeing, but you can't understand how they are being composed to form a new abstraction. You understand the different pieces, but you don't quite understand how those are being combined to form this new idea. It could be you were fine with the abstractions and the treatment seems clear, and in that case, work through it to develop an intuition. Put that time in, experiment, play with it, work at it, and you maybe get it eventually. Sometimes it really does take some time and some effort to understand it, to climb that hill. Or it could be that what you're reading is a poor treatment of the material. Be aware, not all books or articles are created equal. And the answer to that is find a better treatment. Go try a different book. Or it might be that you're rusty with the abstractions being used. So go review those abstractions. Relearning is easier than learning usually. And then come back. All right, so hopefully that's helpful. I actually was, I loved this when I first found it because it really, it helps me. It helps me be more methodical and break down some of the mechanics of what to do when you're stuck. Okay, let's move on to manuals. Manuals are often overlooked, but are one of the richest sources of understanding that you can find about a system. The reason for that is that they're systematic, by which I mean they're thorough. And they cover everything that you need to know about how the system works. Manuals are not, I think, appreciated by most programmers these days. We live in an age of instant gratification, and we want to go quickly find our problem on Stack Overflow, plug in the answer, and move on. And in some cases, that's fine. And I'm glad that Stack Overflow exists. Don't get me wrong. It's a wonderful resource. But don't cheat yourself out of understanding. And manuals are one of the best ways to actually get an understanding about some technology or some tool. Some of you will prefer to avoid reading where possible. If you can find a systematic treatment of a topic in some other medium, for example, in a screencast, good for you. A lot of times you're going to have to pay for such a resource. But if you're willing to do that, go for it. More power to you. But often I found at least such things don't exist. A screencast tends to pick on things that are like easily demoable or flashy or, a really a cool story to tell or something. And they tend not to be as systematic because they're trying to keep your attention. They're trying to sort of entertain you while they're teaching you and trying to make learning as easy as possible. I think that's a good goal. But I think sometimes, unfortunately, learning just, some things are a little bit more tedious. Some things aren't as exciting and fun. Sometimes you just have to work through it and get it into your head, make it a part of you. And there's just not a fun way to do it. It's just not a fun topic. And for that reason, maybe there's not a screencast for it, but maybe there is a manual, a boring old manual for it. And maybe it's worth your time to actually read the manual or the book. Manuals tend to be like for some tool or some program or some technology. Books tend to be, if I wanted to learn about how to build a web app, I might go for a book rather than a manual. A manual is more like, for example, actually I read the Vim manual in college, Vim being the editor from like the 80s or whatever. So manuals more often about a particular piece of technology. But I read through the Vim manual in college, and I have always been glad I did. I actually found it really interesting. I think I've always been a little bit wired to pursue understanding for some reason, to really understand things deeply. So I wanted to read the manual. I found out about Vim from a classmate who was a little bit farther along than I was, and he said, "Jeff, you got to learn Vim." I was like, "Okay, well, what's that?" And he was showing me, and I was like, "Oh wow, that's really cool." So I looked it up and read about it, got familiar with it, and then I started just going through the manual systematically, chapter 1, chapter 2, chapter 3, and man, I learned so much, and I got really good at Vim. And before long, I was showing him tricks and kind of running circles around him. I mean, and I mean that's a good feeling. That's not that you want to learn a manual to show off, but again, pursue mastery. Mastery is satisfying. Mastery is a rewarding thing. Furthermore, another benefit is that the time that I spent reading them has paid off so many times over since then. I mean, that was 20 years ago now, maybe not quite. That time has paid off so many times because I fly when I edit text because I know how to do it well. So again, this is pointing to the idea that like sometimes it pays to be the tortoise. Slow and steady wins the race, and I've gotten farther faster because I was methodical then and actually understood stuff rather than just doing the minimum that I needed to get a job done.